Before we talk about desktop virtualization, I first want to give you a definition of virtualization to make sure that we all have a good base understanding of what virtualization is. When people talk about virtualization, many times they're referring to server virtualization simply because that's the most common form of virtualization. With server virtualization, you consolidate multiple physical servers in the data center into fewer physical servers by adding a hypervisor layer. In this case, you see you've got the VMware layer right there. That's VMware vSphere, assuming you chose the vSphere hypervisor. And then on top of that would be your virtual machines. These virtual machines contain the operating systems and applications from the physical servers that you consolidated into this single physical server, or it could be multiple physical servers, depending on how many virtual machines you're going to put on each server once you virtualize. So the definition of virtualization in the dictionary or on Wikipedia is an abstraction layer, meaning it abstracts the operating system from the hardware. So with a typical physical server, you install the operating system right on top of the hardware, and it has drivers that talk to the hardware. Well, it doesn't work that way with VMware. You create the virtualization layer there, let's say with VMware vSphere, or with another hypervisor like Citrix Xen Server or Microsoft Hyper-V, whatever it is. If it's a Type 1 hypervisor, which means it installs directly on the hardware, you create this additional layer between the hardware and the operating system, and then you've got these multiple containers that contain your virtual machines. So the operating system is actually running inside each virtual machine, and that operating system has virtual devices. So those virtual devices go through the VMware layer or the hypervisor layer to talk to the physical devices. So this is what virtualization is in general. And there's multiple types of virtualization. There's desktop, application, hardware, and there's multiple types of virtualization. There's desktop, application, network, storage, and even others. With desktop and server virtualization, they work very much like this. So those containers that you see there, those virtual machines with the operating system and application inside, instead of being physical servers that you consolidated, like Exchange servers and SQL servers and web servers, those containers could be end-user desktops. So you could have Bob's PC and Sally's PC and Joe's PC, each of those running inside those containers as virtual machines. Here's a little bit different picture of it. At the bottom layer here, you've got the physical server. Of course, each physical server has its own CPU, RAM, and I/O devices like network cards and storage HBAs. On top of that physical server, let's say that you chose VMware ESXi, the vSphere hypervisor. Of course, you could also choose Hyper-V or Citrix Xen Server, but you create this hypervisor layer that installs on the physical server. And then on top of that, you've got the containers there, and those are the virtual machines. And each one has its own virtual CPU, its own virtual RAM, and its own virtual I/O devices, virtual network interface cards, virtual storage adapters. And then you install the operating system and the applications on top of that. And in the case of desktop virtualization, the end users connect to these virtual machines, they get their desktop, they run those applications, they use those virtual devices to connect to the network or to connect to their data that's going through the virtual I/O devices to the storage area network. So in this diagram here, you've just got two virtual machines, but the typical server could have 30, 40, even 60 virtual machines, depending on how powerful that physical server is. All right, so that's our definition of virtualization in general. And now let's move on and let's talk about desktop virtualization more specifically. So let's say that you chose VMware View as your desktop virtualization solution. It uses VMware vSphere as the hypervisor. So you see the three racks of servers there. You got a bunch of servers. On top of those servers, you loaded VMware vSphere as the hypervisor. And then one of the servers is your VMware View Manager. So this is also a connection broker. This is where your end user devices, whether they're thin clients, desktops, or local mode laptop computers, this is where they connect. They connect to that connection broker or the VMware View Manager, and it's going to direct them to their virtual machine desktop that's running on top of VMware vSphere. So as a manager, you would use the VMware View Manager to administer the virtual desktop infrastructure, and the end users are connecting through the View Manager to their virtual machine desktop, no matter where they are, if they're out on the internet, if they're at another company's site, if they're on their mobile device like an iPad, or if they're sitting in their cubicle at the corporate headquarters. No matter where they are, they're going through the connection broker to get to their virtual desktop. That desktop has all their company applications, it has access to their user data, and it's all stored in the data center just like all the other enterprise-grade applications. So in general, that's how desktop virtualization works. But what is VDI? You may have heard people talk about desktop virtualization. You may have heard the term VDI. What's the difference between the two? Well, VDI is Virtual Desktop Infrastructure. That's what it stands for. VDI is pronounced as an initialism, not as a word. So it's VDI. It's not VDI. Most people consider VDI as desktop virtualization. They consider them to be the exact same thing. But technically, VDI is the infrastructure, the hardware and the software that makes desktop virtualization possible. So VDI is all the stuff in the data center that makes desktop virtualization possible. If you're connecting through your virtual desktop, you're using desktop virtualization to access the virtual desktop infrastructure. Still, people throw these terms around all the time as being the same, and that's okay. A little known fact is that VMware actually coined the term VDI, and today it's become a generic reference to desktop virtualization, not to a particular vendor. So if you say that you're using VDI, it could mean any vendor's desktop virtualization solution or any vendor's VDI solution. And we'll talk about various solutions later in this video training series, solutions from Citrix, Microsoft, and VMware. Now let's talk about how desktop and server virtualization are different. And I think by the end of this discussion, you'll find out they really aren't that much different. In fact, they're more the same than they are different. With server virtualization, you're virtualizing physical servers in the data center. With desktop virtualization, you're virtualizing end-user desktops in the data center. How it works is virtual desktops are connected via a connection broker, and the virtual desktops are usually what they call linked clones from a single image. So what that means is you can create the perfect golden end-user desktop. It could have Windows 7, all the patches, every one of your applications, your antivirus solution, and it could contain everything that that end user will need to do their job. And then what you could do is you could give 1,000 end users access to that one desktop, but that golden image isn't changed. Only the changes that they make as they use the desktop over time are changed, and they're stored in a separate file. So each user's file contains just the changes to the golden desktop. So the golden desktop is always preserved. That way, by not every user having their own virtual machine, you're not going to use up as much space on your storage area network. And additionally, when you need to make changes to the golden image, you can just change that one golden image. You don't have to change 100 end user virtual machines. So really the difference between desktop and server virtualization is what it is that you're virtualizing. With server virtualization, you're virtualizing servers in the data center. With desktop virtualization, you're virtualizing end-user desktops and bringing them into the data center. They're the same because they all end up running on the same hypervisor, potentially on the same virtual host even, and very likely in the same data center at your company. Desktop and server virtualization are much more similar than other forms of virtualization like application, network, and storage because desktop and server virtualization both use a hypervisor and they're both creating virtual machines. Just the virtual machines are serving different purposes. Now let's talk about how desktop virtualization works. On the left-hand side, you've got the user experience, as they call it, which is just the end user device that they're using to access the virtual desktop in the data center. So it could be a thin client device. It could be even an existing desktop computer or a laptop computer. They access their virtual machine in the virtual data center. That virtual machine is really broken up into 3 different pieces: the operating system, the user data or their personalizations, and then the applications. Typically, these applications have been virtualized using application virtualization. So now let me show you what it looks like for an end user to use desktop virtualization. If I bring up my VMware View client, this is just a small client I installed on my local laptop computer. The connection server was automatically populated here at installation. I'll just click connect. Just like the typical desktop PC here, I'm prompted for my Active Directory username and password. I'll log in as Bob. And then I'm given a list of desktops or desktop pools that I have access to. By the way, as an administrator, I could also configure them to automatically be directed to a pool and not have a choice here. So I have one pool, and actually it just has one desktop in it at this point in my lab. So I'll just click Connect, and Bob is given access to his desktop running as a virtual machine in the desktop virtual infrastructure. I can access all my company applications here, just like I did before, and even pull up my favorite websites. So that's what it looks like to an end user to access their virtual desktop. So let's close that out and let's talk a little bit more about what makes this possible. No matter what desktop virtualization package you choose, the concepts that you see here are still going to remain the same. You'll have end user devices, thin clients, desktops, and laptops, or even mobile devices like iPads. They're going to connect to the connection broker. The connection broker is going to direct them to their virtual desktop running in the virtual infrastructure. From there, they'll have access to the OS, their user data, and their applications. And speaking of applications, let's talk about how desktop and application virtualization work together. So just as desktop virtualization decouples the operating system from the hardware, application virtualization decouples the applications from the operating system. And I know at first that's a little confusing to understand, but how this works is the applications suddenly don't require installation in the operating system to be used anymore. Because of this, they're far more easily managed, and they're also independent from the operating system. So the applications can suddenly look like just single executables. So you could have Microsoft Word just as Word.exe. You run it, there you go, you're running Microsoft Word. You never had to install it. You could put it on a USB flash drive. You could run it over the network. You could have end users run Word 97, Word 2003, Word 2007, and 2010 all at the same time on the same computer because none of them had to be installed. Most VDI implementations today use application virtualization with desktop virtualization to make it easier to manage the end user applications. Again, that's because application virtualization separates or decouples the applications from the operating system. So suddenly you can manage the end user virtual machines in three distinct pieces: the operating systems, the applications, and the end user data. In fact, in some cases, application virtualization is managed from the same interface as the desktop virtualization solution, and end users or their devices can be assigned individual virtualized applications. That's how it works with VMware View and ThinApp, but other desktop virtualization solutions may work differently. So examples of desktop and application virtualization solutions, like I said, VMware View and ThinApp, also Citrix XenApp and Citrix XenDesktop. Now let's cover the advantages and limitations of VDI. I'm not saying it's perfect, but there are many advantages. So I'll list out both the advantages as well as the limitations. First off, on this slide we've got the advantages. The advantages include data center capabilities for virtual desktops. The desktops get disaster recovery, enterprise-grade backup that's already in the data center. You're already backing up servers. You could also back up even just the golden image of the virtual desktop infrastructure. You're not going to have problems backing it up like you do end user desktops because it's always on and it's always in the data center on the local network. You'll gain high availability, potentially, if you want to implement it, where you could use features like VMware High Availability, such that if a physical server running virtual machine desktops or end user desktops goes down, those virtual machines can be automatically restarted on another server in a matter of minutes. And today, that's not something an end user is going to enjoy if the hard drive or the motherboard goes out on their physical PC at their desk. You'll get a low cost of rolling out new applications and operating systems to end users. So you can very quickly test out applications because the end users can test them side by side. And then once the end user feels comfortable, you can just change the executable from one app to the other app because the application's been virtualized. Same thing with the operating systems. You could have an end user test a new operating system with their applications. Once they feel comfortable, you could simply replace the golden image operating system with the new golden image operating system that you want to upgrade to, and then all the users get that same operating system. Their applications have been virtualized, so they're going to run on that operating system. I mean, you already tested them, and then their application data is separate. So you can roll out apps and operating systems quicker than you ever could before. You may be using imaging software today to image desktop PCs, but I know personally that it takes a long time to image a PC and a long time to write an image back to PCs that you want to clone. With VDI, imaging is basically just built in to using desktop virtualization, and then for most desktop virtualization solutions, the feature of linked clones is also built in such that you've got one golden image, and then end user desktop changes to that image are stored in separate files. So you really only have one golden image for all the end users that they're accessing. You don't have 100 virtual machine images taking up tons of space if you have 100 end users. Also, you get to separate user data programs and the operating system, as I talked about. The refresh cycle for end user devices can now be much longer if they're using thin client devices, or even if they have old PCs. They can keep those old PCs and just run the desktop virtualization client to connect to the VDI infrastructure. They can keep the same old PC and suddenly they can run Windows 7, Windows 8, and all the greatest applications that your company wants to buy, because all that's now running in the data center. So the refresh cycle for the end user devices can be much longer. They can keep the same thin client device and go through multiple operating systems and applications. It doesn't have to be replaced as often, and a thin client device isn't going to break as often because it has no moving parts. You'll get easier remote access for end users to their desktops through various devices. No more slow VPN access to transfer large files or try to run applications over a wide area network. VDI provides consistent access to the same desktop no matter where the end user is. And then finally, you'll get tremendously quicker provisioning of new desktops. For example, an end user walks in, they're brand new, they just started today. They say, hey, I brought my own laptop. Can I use this? You say, sure. Here's the VDI client. Connect. There's your desktop. It's got all the apps. Now go to work. No more do you have to say, well, what kind of applications do you want to run? Let me spec you out a PC. Let me order it. They're going to have to build it. They ship it. We get it. Maybe we make customizations. We bring it to your desk. You know, all these long series of steps that traditionally had to be done to provision just one single brand new company employee's desktop can now all be eliminated thanks to VDI. And now let's talk about the limitations. So limitations of VDI. First off, the initial design and setup can be more complex than the way that you're doing it now. So you have to put some forethought into VDI. You don't want to just have one server and then try to connect all your users to it. You need to consider how many end users will you have? What's the scalability of that server? What about high availability? You need multiple servers. Well, what about storage? What about higher performance storage? You need a storage area network. You know, these things need to be thought of ahead of time. Certain applications can cause issues and not perform well. For example, let's say that you have a group of graphic designers that need to run AutoCAD that may not work very well over a virtual desktop using a thin client device. You'll have to test it. There's special thin client devices that are better suited for graphics. There's better protocols in use that you can employ for high-end graphics and still use desktop virtualization. But still, you need to keep special case applications in mind. Another limitation of VDI is that remote users are now suddenly dependent on a connection to a central data center. So let's say that you have 2,000 remote offices, all connected by a wide area network to a central data center. If that's where all the virtual desktops are running, and if your WAN link goes down to the 2,000 remote offices, suddenly they have no desktops at all. So keep this in mind when you're designing. You know, think about these what-if scenarios. Maybe you need to have two different regional data centers, each with redundant desktop images so that they could reconnect to a different pool and still be able to run their applications and be able to do their job and make the company money. Data center and network downtime can cause all users to be down. Also, if even just a single site loses their network connection, that whole site could be down. So these are all design considerations that you need to think of before implementing VDI. VDI may have some higher upfront costs, but those costs, in my opinion, will be returned in the long run with a much lower support cost. Central data center and network must be properly designed and understood. And maybe that isn't really a limitation, it's really just a requirement. And I mean, you should today understand your data center and network properly as well. But when you start pulling all the end user desktops into the data center, this just becomes so much more important. So these are just some of the limitations, and perhaps not really a limitation of VDI, but just kind of gotchas that could come up that you need to keep in mind.